A by TTOF explanation. The principle in a nutshell. Rob Laudenberg. Prim coil sector 2 coil sector 1 coil PS2 PS1 AC no load 1. Confidential November 20, 2010 2 core. Rob Laudenberg. No load 2. November 20, 2010 confidential 3 primary core small volume near saturation high flux reluctance uses large part of the BH curve HB used BH area IPRIM time 1122. Rob Laudenberg. PS2 PS1 AC on load S1 PS1 S2 S2 S1 S2 P prim coil RR on load 1. Sector 1 coil sector 2 coil confidential November 20, 2010 4 core. Rob Laudenberg on load 2. November 20, 2010 confidential 5 secondary cores big volume no saturation, low flux reluctance uses only small part of the BH curve HB used BH area Isaac time 1122. Rob Laudenberg flux initial P, S1 create near saturation, PS2 end primary flux making the primary core a high reluctance core part PXX caused by the load resistors at secondary counter flux coils are created in non-saturated core parts and have low reluctance. The secondary fluxes can choose between a high reluctance path or a low reluctance path. Most of the secondary flux will travel the low reluctance path, through the secondary cores remaining secondary flux will travel through the high reluctance path. Through the primary core flux flow can be compared with current in a parallel resistor circuit. V represents the secondary flux source, 10 represents the secondary cores as seen by the primary, causes large flux flow. 10K represents the primary core as seen by the secondary, causes small flux flow. 10K VI1 I2 plus. Confidential November 20, 2010 6. Rob Laudenberg coil flux couple coefficients. The bit employs mutual and non-mutual coupling coefficients in symmetric and non-symmetric ways. Mutual coupling, primary to secondary 1 asterisk, 0.5, primary to secondary 2 asterisk, 0.5, secondary 1 to secondary 2, 1, secondary 2 to secondary 1, 1, non-mutual coupling, secondary 1 to primary, 0, secondary 2 to primary, 0, asterisk note, the coupling coefficient is actually 1 but each secondary only gets 1/2 the primary flux, which is akin to saying a cc of 0.5 when in fact it is actually a cc of 1. Prim coil sector 2 coil sector 1 coil confidential November 20, 2010 7 core. Rob Laudenberg primary saturation area flux tuning November 20, 2010 confidential 8 in the bit. Ideally, secondary flux is 0 degrees in phase with the primary flux. This will block the flux in a maximized way from the secondary coils by optimizing saturation of the primary coil. Time I prim secretary bit primary flux result secondary flux phase of a common transformer primary flux result. As a reference, the secondary flux of a common transformer will be 180 degrees out of phase with the primary flux. This leads to decrease of the primary core saturation and decreases the impedance as seen by the power source at the primary coil. Rob Laudenberg power factor on no load bit borrows asterisk mostly reactive power, PF00 on load. The bit primary coil borrows asterisk mostly reactive power, PF0. Class may slightly differ due to flux flow from secondary to primary coils, causing a slight decrease of PF with an estimated correction class, 0. Confidential November 20, 2010 10. Consumed and delivered power consumed and returned power asterisk, consumed power is equal to the real power consumed, effective voltage time effective current times cos, phase angle, returned power is equal to the reactive power, effective voltage x effective current x sin, phase angle, mainly determined by the impedance of the primary coil bad couple factor, CC0, between secondary and primary coils may add extra consumed real power delivered power driven by flux generated by primary coil in theory infinitive, but in practice limited by load value and internal coil resistance of secondary coils is angle between voltage and current asterisk.